Each year, on American roadways, more than 8,000 traffic accidents resulting in serious injuries or death are attributed to tire failure, according to the National Highway Traffic Safety Administration. Modern radial tires are designed to withstand extremes of pressure and heat, but tire failure-induced accidents peak during the hottest months of the year. The weakest part of an automobile tire is the area where the sidewall meets the tread. When a tire gets too hot, this joint can separate and result in catastrophic tire failure. A blowout. Running over sharp objects, hitting curbs or potholes, and tire manufacturing defects can also cause blowouts. But what if there were a simple, inexpensive system that could monitor the interior temperature of a tire as it rolls along the highway? What if this same system could warn a driver when tire temperatures become unsafe, or even if structural damage occurs? And what if this revolutionary, potentially life-saving technology was already here, today? In 2008, two researchers at NASA Langley Research Center received an R&D 100 award for their development of Sansec sensing technology, a revolutionary new technology that allows sensors to work without any electrical connections. This astonishing advancement reduces sensors to a single component, a single open-circuit pattern of conductive material that has allowed for the development of sensing devices not previously thought possible. Because of its open-circuit design, there is no point on this sensor that, if broken, prevents the sensor from functioning. In essence, the Sansec sensor is designed to be used where other sensors fail. The way it works is simple. When powered by an external oscillating magnetic field from an interrogation system antenna, the sensor produces its own magnetic and electrical fields, which extend beyond its surface. The sensor-produced magnetic field is then detected by the antenna. More recently, researchers at NASA Langley have discovered another foundational way that sensors can be developed, adding to the groundbreaking advantages and attributes of the Sansec sensor that were previously presented. A temperature-sensitive material can be coupled to the sensor through its electric and magnetic fields, and any temperature changes to that material will affect the sensor's resonant frequency. In one design, there is no need for one component of the sensor to physically contact any other components. In the other design, the conductive trace can be embedded in the temperature-sensitive material. We've seen the effect that extreme temperatures can have on automobile tires. The Sansec temperature sensor can be installed in tires and other non-stationary objects that cannot be hardwired. The sensor within the tire is powered by the magnetic field from a nearby antenna, and its responding magnetic fields are interrogated by the same antenna. As the rotating tire's temperature is raised, the temperature and rotation speed can be measured concurrently, and that information could be relayed to a vehicle's operator, possibly alerting them to an unsafe condition. The wireless temperature sensing capabilities of the Sansec temperature sensor are impressive, but the innovations don't end there. In addition to temperature, the Sansec temperature sensor can be used to measure other parameters. In fact, just one sensor can measure up to 3 parameters, such as temperature, rotation speed, and damage, all concurrently. The Sansec temperature sensor can be used to measure rotation speeds with great sensitivity, even when the measured object is moving at very high speeds. The Sansec temperature sensor is also incredibly durable, allowing its use in harsh, unforgiving environments. Most current generation wired sensors fail when their circuit is damaged or broken. But as seen here, the Sansec sensor not only continues to function normally even after absorbing catastrophic damage, such as a nail puncture, but the sensor can even detect the damage and trigger an alarm. Due to its simplicity, its wireless functionality, and its low cost, there are many other potential applications for this type of technology. One such notable application is in food packaging. After packaging, but before consumption, many products are subject to a variety of conditions during transportation and storage. Most of these food products are not continuously monitored for extreme variations in temperature or humidity, conditions that can lead, in some cases, to widespread recalls of spoiled products. A simple, low-cost sensor could be applied to sensitive medical or food packages or their containers. Temperature-sensitive products could be monitored, alerting retailers to possible spoilage issues and, ultimately, protecting the health of consumers. Again, unlike most sensor designs of the past, the Sansec temperature sensor will operate even when significantly damaged. If a sensor is punctured or torn, for example, it simply becomes a new sensor or multiple sensors which continue to operate normally. As long as the sensor can store electric and magnetic energy, it will function. Other applications for the Sansec temperature sensor could take widely varied forms and profoundly affect many different industries. The Sansec temperature sensor, the game has changed.